Each of the factors that we discussed in the previous video help to determine a good's elasticity of demand. Knowing about these factors can help you predict whether demand for a good is more likely to be elastic or inelastic. However, demand for a good can be affected by several of these factors at the same time. So if you are trying to predict the elasticity of demand, you have to take account of several factors at once. Consider the example of cars. Okay? Many people think that cars are necessities rather than luxuries. This suggests that the demand for cars would be inelastic. But buying a car is also a large part of many families' budgets, a factor that tends to make demand elastic. The actual elasticity of demand for cars at any time is influenced by both of these factors, one which makes it more inelastic and one which makes it more elastic. And it can be influenced by other factors too. In some cases, however, one of the factors has a larger influence on elasticity than the others. This allows us to make a good guess, based on that factor alone, about the elasticity of demand. The table here in this slide lists determinants of the elasticity of demand. For each determinant, the table lists a good for which demand is predictably elastic or inelastic due to the influence of that determinant. So you should pause the video now and spend some time studying this chart and getting an idea of how these different determinants of elasticity of demand influence different products. Elasticity of demand, which is consumer sensitivity to a price change, can be measured numerically. So now we're going to learn how to calculate the elasticity of demand for a good. To calculate it, we divide the percentage change in the quantity demanded by the percentage change in the price. For example, if a 10% rise in the price of chocolate bars causes the quantity demanded to fall by 20%, then the elasticity of demand is 20% divided by 10%, which would equal 2. Technically, the elasticity of demand is a negative number. Because a rise in price, a positive percentage change, causes a drop in the quantity demanded, a negative percentage change, the number that results is always going to be negative. But to keep things simple, economists usually ignore the negative sign, and that's what we'll do when discussing elasticity of demand. That is why the elasticity for the chocolate bars in our example is 2 instead of negative 2. Now, let's see exactly how to calculate the elasticity of demand using information from a demand graph. The figure that we looked at previously showed 2 demand curves for large chocolate bars in a small city. So let's go back to that graph. In both of these graphs, the price per chocolate bar is measured on the vertical axis, and the quantity that is demanded